we'll be working with all these drawings that you see on the screen, and we'll be starting with some basic tools to understand what we are trying to do here. First thing is, let's see what a circle is. Okay, so to draw a circle, there are a couple things that we need. First of all, we could draw a circle with the use of a radius or a diameter. Okay, now what is that? Radius is, if you look on the drawing to your right, where I have this octagon, you see the circle that has been drawn. The circle has been drawn at a radius, or in this case, it's a diameter of 6. Okay, so the radius of the circle, if we would say, would be half the diameter, which would be 3.0, right? So the symbol for the diameter is always drawn as a circle, and then you put a slash like an angle, right? So this is the symbol for the diameter, and the symbol for the radius, which you would see somewhere. Let's see, where's the radius? Okay, we don't have a symbol for the radius here. Oh, right here. Okay, so the symbol of the radius is drawn just as R 3.0. Diameter is drawn as diameter 6.0 for the same exact circle. So what you see is the diameter is twice the size of the radius. Okay, now let's draw a couple simple examples. Now in the first case, what I would be trying to draw is draw a circle with a radius of 3 or a diameter of 6. Usually circles are always associated with a diameter, not a radius, but just so you know what a radius is and what a diameter is. So I'm going to take the center of something over here, right? And I'm going to put my protractor, sorry, not the protractor, I'm gonna use my compass. Now if you don't know what a compass is, I explained it in the previous part. It looks something like that, with, you know, with two angles, and over here you have a sharp edge, and on this side you have a pencil, right? So you would be using the compass to draw your circle. So what I would do is put my sharp end of my compass right here and my pencil end right here, and just go ahead and draw my circle. Okay, so this is a circle at a diameter, which is that symbol, of 6.0. Now if you can see, I have 1, 2, 3, 4, 5, and 6 squares, right? So if I were to draw a circle with a diameter of 6, that is how I would draw it. Now let's see a few more simple examples where I would draw a circle. How to draw a circle with maybe one line going this way and the other line going this way. Now if I were to draw a circle with this information, I could always freehand draw it by just joining all the endpoints, okay? And that gives me the circle with a diameter of what? With a diameter of 4.0. Okay, so this was a simple example of how to draw a circle using a diameter. Now let's do one example where we are going to draw just straight lines using my ruler. This is one, and that's another line. So this is line A, I would call it. This is line B. Now if you look, the angle on this side is 90 degrees. Now my exercise is to bisect this angle for line A and line B, which is 90 degrees. Now how would I do that? Using my compass. Okay, so first thing what I would do is put my pointed edge of the compass right on this corner, draw an arc with my pencil edge a little more than half. Okay, so two of these arcs in the same distance, little more than half. Now what I get is an intersection there and an intersection here. Now putting my compass on line A at this intersection, I would draw another arc going that way. I'll do the same thing, put the pointed edge on line B at this intersection and draw another arc going this way. Now the size really doesn't matter, it just has to be a little bit more than half, so you make sure that these arcs are intersecting somewhere, which is right here. Now to complete my bisection, all I have to do is draw a line from the new intersection going all the way till the end. So if I were to measure it, this would be an angle of 45 degrees. And that would be the same, 45 degrees. So this is how I would bisect two lines which is at a certain angle. If I were to do a different angle this time, I have an angle that goes like this. This probably is maybe, I'm just going to put a number, maybe 70 degrees. Right? How would I do this? Again, I would just put my sharp end, pointed end of my compass on this side, draw an arc which is a little bit more than half with my pencil edge. So I am cutting my two lines right here and right here. Now I'm going to put my sharp edge of my compass on one of the intersections, make another arc going like that. I'll put it on this intersection now, make another arc going this way. So what I have over here is my new intersection for my arcs. All I have to do is join a line from there going to the point of my angle. So now what you see over here, I've already bisected my angle at an angle of 35 degrees. Okay, so I hope you understood how to just do some basic bisecting of angles, because that's what we will be using on all our exercises on the other side. Okay, so let's do another example where I would be drawing an octagon. The one that you see on this side, I'll be drawing an octagon with the distance between the flats of 6 inches. Okay, so flats are the flat surface that you see on the top and bottom, side and side, right? So I would be drawing that, and let's see how would we draw an octagon. Now octagon meaning it has 8 number of sides, right? So if you see 1, 2, 3, 4, 5, 6, 7, 8. So it's really easy to draw an octagon. So to start with an octagon, first thing I have to do is what? Is start with a circle. You see the dotted line over here, which is the diameter of the octagon, which is for 6 inches flat, right? So I'll use a diameter, and I use a circle of diameter 6 and draw my circle first. So I go, let's see, let's try to stay within the scale. So I go 3, approximately 6, right? Let me do it again. I just didn't do it right. So 6 is going to be, I'm going to have my center here, and I go there, go there. It should be nice and clean circle, even though mine is not the best, but I hope you get the idea, right? So I did my inner circle. Now this is just a guide that I have, okay? I really don't need that later on once my octagon is done. So the next thing I would be doing is draw a straight line going down here, draw a straight line on the top, aligning my slider, draw a straight line touching the circle on this side as well as this side. Now what I have is a circle enclosed in a square. Now the next thing I would have to do is just draw the 45 angle that you see tangent to my circle. So I would put my triangular, remember I talked about the triangle? It looks something like that. I put my triangular scale right about here, which is at a tangent to the circle, and draw an angle of 45. Same thing, I would do it on this side as well as this side and that side. Now pretty much my octagon is done. All I need to do is just highlight my lines. Main thing I had to remember is this angle has to be 45. Now you have 45, right? All these angles are 45. 45. And now I can just highlight my octagon. 1, 2 sides, 3, 4, 5, 6, 7, and 8. Okay, so that's the octagon that I created, and if I would measure it, this distance is going to be 6.0. Same thing would be this distance between the flats, which is how much? 6.0. So this is the process of drawing an octagon with a distance of 6 between the flats. Okay, now let's go to the next one, where instead of an octagon we are going to draw what? We are going to draw a hexagon. Let me just bring that up. I'm going to delete this part, and I'm going to just delete this so it cleans up my drawing. Now let's go to this one. This is the hexagon. This is the one that I want to draw right now. Now the hexagon, the difference between hexagon and octagon is hexagon has 6 sides. And the second difference that you see is the difference in the angle. This is 45 and this is 30. Rest everything remains the same. So I'm going to start with the same exact process. I'm going to make a circle from the center. And how much is the diameter going to be? 6. So let's go make a circle from the center with the diameter of 6. Okay, so that's my circle, which you see dashed on your right. Now the next thing I would do is again the same exact way. I'm going to draw a horizontal line here, horizontal line on the top, and to continue I would even go draw a vertical line this way, a vertical line that way. Now the only difference I said was the angle. Now in this case the angle is going to be 30 degrees. So I'm going to put my triangular adjustable scale, same thing, adjust it to 30, 60, right? So I'm going to make an angle going this way at an angle of 30 degrees. Okay, at an angle of 30 degrees, 30. Then I would do the same thing on this side while I'm already there. Okay, do the same thing on this side while I'm already there, and again this side while I'm already there. So now my hexagon is already done. All I have to do is go ahead and highlight my lines. Okay, so I'm going to go to the first one, 1, going to go down there, go down here, again do this angle, to that angle, and this angle. So how many sides did I get over here? 1, 2, 3, 4, 5, 6. All of them are at angle of 30 degrees. So that completes my hexagon. Okay. So when you try to draw this and just follow the steps, you shouldn't have any problem doing it. Okay. So I just finished drawing the hexagon. Now let's do some more exercises that you see down here below, and then I would get into a little bit more complicated stuff. Okay. Now let's do this one. Let's do this one. Now the question over here is construct an arc with radius of 3 inches and tangent to line E and line F. Okay, now this is a really simple example, but main thing what we need to do is construct this arc from this line and this line. So how would we do that? To do that, what I will do is first start with obviously having the line in there. So I'm going to take that. I draw one line, which is line E. And I draw another line, which is line F. Right? This is line E and that's line F. Now to draw this radius or an arc, you need to find the center of this arc. Now how am I going to find this center? So that's why we have to go through this process. So first thing I would do is the information given to me is the radius of 3, right? And tangent to line E and line F. So I will take my scale, measure the distance 3.0 on this side and 3.0 on that side, and just draw lines that are parallel to that. That's the line F, parallel to line F, and this is parallel to line E. So what I get over here is one intersection. Now what I need to do, the second part, is draw my tangents to these lines, because if you see the arc goes to the tangent, right? So this is one tangent and this is another tangent. So how do I draw those tangents? All I have to do is go to my point of intersection, which I just got, and go make a straight line or a 90-degree line going to what? Going to line F. I would do the same thing to the line E, draw a line going from the intersection to line E, and which is 90 degrees. So I already found my tangent points, and one tangent point is right here and the other tangent point is right there. Okay, so using this tangent point and this intersection point, I would be drawing my arc. So I would go and just keep my pencil off my compass onto these points and then just draw that arc. The sharp edge of my compass would stay right there. Got it? So if I go ahead and measure this distance, it's going to be a radius of how much? A radius of 3.0, just as it asked for over here. Okay, now you could just go and highlight it. So this is what I got, right? Now everything else that we have is more of a reference line, but this is what we needed from that center of a radius of 3.0 tangent to line E and tangent to line F, right? So I hope you understood this video. Now let's go to the next one. Now the next one is construct an arc with radius of 2 inches tangent to arc G and line J, right? Now what's the difference between this one and that one? This one had a line and a line, and this one has what? An arc and a line. The process still remains the same. First thing we need to do is find the intersection like we found over here. Second thing we need to do is find the tangent points. And the last thing is, after we found the tangent point, we would just go ahead and put our arc, right, tangent to these. So let's get to that example. First thing I would do is have my arc, which is right there. I'm going to use another color maybe, or yeah, let's use another color, the thinner one. So I'm going to draw my arc G, which is at whatever radius. Now the arcs are always associated with a radius and circles are always associated with a diameter. Okay. Now the next thing I would do is draw my line, which is line J, and this is arc G. Okay. Now I know it is the arc with the radius of 2 tangent to this one and that one, right? So same exact process. Instead of taking 3, I'm going to put my center of my compass right there, the sharp edge, and draw a distance of 3 from the outside of my arc, or sorry, not 3 but 2. And then with the sharp edge over here, the pencil edge on this, I'm going to draw another arc. I'm going to do the same thing for my line that you see here. I'm going to get a distance of how much? Of 2.0, and draw a straight line to where it intersects my arc, which is right here. Got it? And the next part remains pretty much the same. I have to find my tangent points. To find my tangent points, what I will do is from that intersection, I'm going to make a straight line, which is how much? 90 degrees. And this is my tangent point for the line. Now I have to find the tangent point for the circle, or for the arc, which is right here, right? So let's find the tangent point. To find the tangent point for the arc, I already have my intersection point here, and I have the center of my arc. All I have to do is draw a line, straight line that connects both of them. Once I do that, I already got my tangent on my arc. Okay, so this is tangent number 1. This is tangent number 2. This is my intersection. All I have to do now is put my arc that you see out here. So I take the pointed edge of my compass, put it right there. Using the pencil edge on this side, I will draw an arc that goes and touches this one, right? So how much is that radius? 2.0. So this is what we were asked to do. Construct an arc with radius 2.0 tangent to arc G and line J. Now let's go highlight that. This is the arc that we were supposed to draw. Okay, so I hope you understood how we got done this tutorial again using the compass and the slider scale. We really didn't use our adjustable triangle for this one, or we could for drawing the vertical line, right? So that's how you would do that specific exercise. Now let's go get into a little bit more complicated stuff, where I will start working with this one and that one, and then we are done with our drawing tutorials. Okay, soon we should be done finishing with this chapter. So let's get to this one. Now first read the question. Is construct arc with 8-inch radius tangent to arc A, which is on your left side, and arc B, which is 3.0 diameter right here, which is on your right side. Okay, and the next thing we need to do is enclose both arcs just like this. So if I were to do it, it would be a perfect circle. Okay, so how would we start with this? First thing I need to do is get my two arcs. So this is arc A, drawing like that with a center, and then we have arc B going like that, okay, again with the center. Okay, both the centers are lying still in the same line. Now it's telling me to construct an arc with radius 8. So this arc has a radius of 8. Okay, if you see, if I join it, this should be 8. Okay, now to do this we have to do a little bit of math, where I have to subtract 8 minus 2 for arc A, which gives me a number of 6. And I will do the same thing, 8 minus 3 for arc B, which gives me 5 inches. Okay, now you have to know arc A is a radius of 2, and arc B, if you look over here, is a radius of 3. That's what we're subtracting from the radius of the big arc, which is our final arc, which we need to draw, which is at a radius of 8. So that's been done. Now what I need to do is put my compass right here, and the pencil edge, I would take a distance between 2 as how much? Between my sharp edge and my pencil edge of my compass, I would take a distance of 6.0. Put the sharp edge right here and draw an arc. Okay, now I would do the same thing on arc B, where put the sharp edge of my compass right here, put the distance on my compass and my pencil as 5.0, which is this, and then draw an arc. So what I just got is an intersection of two arcs. So the next thing I have to do is get my tangency points onto this arc as well as this arc. Now how would I do that? It's really easy. All I have to do is join my intersection point with the center and let it go till extended till where it hits the circle. I would do the same thing on this side till where it hits the circle. Now this and this are my tangency points. Now that I found my tangency point, to complete the exercise is really simple. All I have to do is what? Is put my compass sharp edge on this side, which is right here. The pencil edge, I will line it up with here, right? And draw an arc connecting both the tangent points, right? So this is my what? This is my tangent of radius 8. This is my arc of radius 8, tangent to arc A and tangent to arc B. So I hope you followed this. Let me just go ahead and highlight. This is what we wanted to achieve. Okay, this is tangent point 1, tangent point 2. This is the intersection. Got it? So just follow this video. You can always rewind it, and then you would be able to do this really easy. Okay, now let's go to this last one that we have, and let's try working that out. Okay, so the process still remains exactly the same, but all these exercises are a little different, so that's why I'm doing it over here. So this question is construct arc with radius of 2 inches, tangent to arc C and arc D. So this is arc C, this is arc D. Now if you see, the radius is a little different. In this exercise, it was going all the way from here till the outside, right? It was an enclosed arc. Now this one is going on the other side. It's going on the inside. So this is what I have to try to achieve. The centers of these circles or these arcs are off as well. In this case, they are straight. Okay, so let's draw this arc, which is arc C. I'm going to use another pen and put an arc, which is arc C, right here. Okay, so it looks a little bigger. I'm gonna make it even more smaller, maybe right here. Now this is arc C. I'll make another one, which is arc D, which is more bigger. Right, with the center right there. Now the next part that we would be doing is construct an arc with a radius of 2. And how would we do that? Just like we did this example. You see this example right here? It's the same way. So what we will need to do is from the center, go out somewhere, right? And from this distance, I'm going to go how much? I'm going to go 2.0, right? I would do the same thing on this side as well, and from here I would go 2.0. All I need to do now is draw my arcs, putting the sharp edge, pointed edge of my compass right here, and make my arch go like that. Same thing I would do, put the sharp edge right here and draw my arc going parallel to that arch. So what I just got is the intersection point, right? Just like our previous tutorials. And the next thing I need to do is find tangent points. For what? To draw my arc, which you see right here. So to find my tangent points exactly the same way that we did in this tutorial, how do we find the tangent point? Connect it from the intersection to the middle of the arc, and this is how I find my tangent. So I am going to make a line from the intersection to the center to find my tangent. Okay, from the intersection to the center, which is lies on the same point right here, and that's my tangent. Now what I need to do is just take my compass, put the pointed end on the intersection, and the other edge, the pencil edge, onto my tangent lines, which is this and this, and then just complete my arc. So if you measure it, that arc is going to be of a radius of 2.0. Got it? Line types and line weights. Okay. Now when we are working with our CAD drawings or our engineering drawings or mechanical drawing, it could be any drawings. So as I was talking in the first chapter, we have to follow the standards. And why do we follow the standards? Again, to make our drawing readable so everyone understands, everyone is on the same page, so everyone understands what you are trying to convey. Everyone can read your drawing, so they can understand the language that you're trying to talk in. So when it comes to our drawing, we do the same things, where when we draw, we follow a lot of different standards, and a couple of the standards would be using different line types and obviously even line weights. Now what you see in this picture over here is an object that is drawn in a two-dimensional view, where you can view the object from the top, from the front, and from the side. So again, this chapter we are going to cover next week, which is orthographic views. But main thing you need to understand is how we use different line types and line weights for working on our drawing sheet. Now if I were to draw a really quick 3D view of the object that we have, or an isometric view, it would be really simple. Just something like that, and I have a circle here, or if it's 3D, it's going to be an ellipse, it's not going to be a circle. And then I have a bigger circle right in the middle, right? And this side I have a cutout, something like that. So this is how the object is that you see. If I'm looking from the top view, all I see is these edges, right? I see those edges. I see 1, 2, 3, 4, 5 circles. Again, if I'm looking in the front view, which is right here, what do I see? Actually, the center circle is going up. It's going up at a certain height, just like that. Okay? So that's the center cylinder, right? It goes up. So what do I see in the front view? So in the front view, I'm seeing this base, which is again this base, right? Front view, I'm looking that way. Then I see this cylinder, which is that cylinder, okay, the big one popping up. And then I even show some dash lines, 1 and 2, right there. And those dash lines are for 1 and 2, are for these holes. But if I'm looking this way, I'm just seeing this surface. Okay? I'm not seeing the top surface. All I see is up till here. And I don't see this. Why? Because this is a normal surface, right? And then I see this part, which is the cylinder. So I still want to show someone that there are these 4 holes that exist. So using these hidden lines, I could show them that there are holes, right? Now again, this is a technical drawing, right? So we have to understand how technical drawings work, how you draw, how you understand the terminology and stuff like that. Looking at this line, this is the center line that I have. 1, 2, and 3 from the front view if I'm looking this way. So one of the center lines is for the big one, the second center line, and this center line is this one and that one. I don't see the 2 behind it because it's exactly falling right behind the front 2 circles. Okay, so then I put the center line, and if someone sees the center line, they already know that it is a hole there. So this makes reading our drawing so easy. So that's why we have to follow the line types and try to understand what the artist or the engineer is trying to tell us so we can manufacture it accordingly. Now, the different types of line types, one of the lines is just the visible line. Visible line is just drawn, just going to use another thicker marker. Visible line is a solid dark line. Now, a visible line in this picture would be that one, this one, this one, that one, the circles, these, everything that you see which is solid, right? It is called a visible line. Okay, now let's get rid of this, clean up our drawing a little. Now there's the next one called as the hidden line. Now the hidden line stands for lines or objects that are hidden. They are usually denoted by a straight dash line. Now in our example, we have hidden line right here, right here, right here, right here. And these hidden lines are for these circles or these holes. Not the circle, it's a 3D object, so these holes. So it is called a broken or hidden line. Okay, I'm going to erase that now. Now let's see what more different types of lines that we have here. Now we have a center line. Now the way the center line is drawn is one big dash, small dash, big dash, small dash, and big dash. So it keeps going on like that, right? This is called the center line. And the center line is always associated with hole. If you have a hole, you should always put a center line. Okay, because that's a standard again. If the center line, if the hole doesn't have a center line, then that means something is wrong. So we see center line right here, small dash, big dash, small dash, big dash. Same thing over here for this hole, big dash, small dash, big dash, small dash. Now why don't I see it for this one and this one? Because when I'm looking from the front view, it's right behind it, so I cannot draw two center lines in the same location. Okay, so that was the center line. Now there's another one called the section line. Now what is the section line? Like if I were to cut my object, this is my object, if I were to cut my object right from the center and look it in that direction, how would it look? So it's basically cutting an object from a certain area or from a certain side and looking at the object that we just cut. Another example would be if there's, an apple and I need to see what's inside the apple. I have to make sure that I cut it. I cut it in half, right? When I cut it in half, I will see some seeds over here, and then I know that that's a cut apple. If the apple is not cut, then obviously it's a solid apple, right? From the top it would look like that. That's the apple from the top. And if I cut it, it would just look like that. Only half of it, right? So that's called a section line. Now I'm going to again clean up some space. Get some more space, clean up our drawing. Okay, so this was the center line, and right here is section line. And how is the section line drawn? It's usually associated with arrows and dash, dash, big one, that's a big dash, small two dashes, big dash, small two dashes, big dash, and an arrow. So this I can call it as A and B. So I can say I cut this object from A to B, and the arrow meaning I'm looking into that direction when I cut the object. So that is my section line. Now there are some more different types of lines that you see. Now the different types would be, more different types would be what? Would be a dimension line, which is this. This is a dimension line. These are dimension lines. Now a single dimension line comprises of what? Comprises of the dimension line within which you have the dimension, and the extension line, which is coming from the surface of another object. So this dimension, this whole thing is one dimension, and it's read from here till here, right, at a distance of 10, and it's within the dimension line. Another thing the dimension line has is what? Is this arrows. You see at the end you have this arrow. So that means the dimension is going from there till here at a distance of 10. Okay? Now we have some more dimensions over here. You see the arrow, the dimension, and the dimension line. So it ends in the center of the circle. Distance starts from the center of the circle, goes to the center of the big circle. Start from the center of the circle, big circle, to the center of the small circle. Now I got a distance of 3, 4, 5, 6, 7, 8. Now what's the distance on this side? Going to be 2.0. Now, so the total, if you look up here, is 10. So that is the dimension lines, and the way the dimension line looks is like that, like this. Don't forget the arrow, don't forget the number 3.0, and lastly don't forget the extension line that goes to the object. Okay, so that is our dimension line. There's some more different types of lines if we wanted to see. Is we have a break line, where if I ever wanted to break the object, so I could put a break line. But now you will understand how the break line is once we work with a certain example. I just don't want to confuse you guys. But then the next one would be even a hatch line. Like for example, if I have an object that I cut out, I could pretty much go ahead and hatch it. I could hatch it with some straight lines, and the hatch meaning cut out object. And this would happen when I am using my section line. So maybe I can just show it to you what exactly the hatch means. So we already know what the section line is, right? This is our section line. Now if I were to draw what got cut out, I would draw something like, maybe I need to draw in a different place. I'm just going to draw over here right now. So that's the block that I cut out, and there's the cylinder, the top one that got cut out. So I'm going to hatch it. Okay, then what else got cut out? Then this object got cut out as well. No? And then there's this line, which is that line. That obviously from here to here I didn't cut it out, it's going from here, right? So my section would look something like that, where I just cut through the object and through the cylinder. I can show my center line, because for every cylinder I need to show my center line. So this is called a hatch line type. Okay, so that pretty much covers most of the line types that we have, but if we come across some other ones, then I would go ahead and explain that later. Now the next one is, just for theory purpose, is line weights. Now what are line weights? Line weights are just lines that are drawn on different weights, that are drawn on different thicknesses. Like you have a pencil edge of H, then you have edge B, then you have 2H, then you have 3H, right? The lead keeps going thicker. So why would we do that? Again, the reason why we would use different line weights in our architecture drawing mostly is when something is further away in the drawing, then I would draw it at a thinner line weight. Like for example, if I'm just going to draw a cartoon house. Now this is our cartoon house. Okay, so I'm using a thicker line weight over here, but when I needed to draw some mountains, right, some mountains behind, some birds flying, I would use a thin line weight. You know what I'm saying? If I had something even more closer, then I would draw using, like if this building was closer than that one, then I would draw using a thicker line weight. So that gives the illusion as this is closer and this is further and this is furthest. Okay, so that's where line weights come handy. So that's a simple example. Now the second example is, you don't want your whole drawing to look exactly the same thickness. Some things in the drawing you want them to read faster, so you would make it thicker. Some things you don't want them to, which is of less importance, so you would make it thinner. Now in our object, now if you look, the front view, the text is a little thicker than my dimension text. Why? Because it's important to show what views they are. So that's why this is a little bit more thicker than this. Now my object lines, object lines are more thicker than my hidden lines or even my center lines. Why? Because I want people to see my object lines more than my section lines or my dimension lines or my center lines. So this is where I would use varying line weights for different exercises and different objects. Okay? So again, when we go with more and more exercises, you might have a clear understanding as to where we would use different line weights. Mostly in engineering drawings, all the object line weights are the same or similar thickness. Line weights are used a lot in architecture drawings than in engineering drawings. So if you're looking onto this object, pretty much everything can still be the same line weight. But the object heading obviously has to have a little bit bolder or a bigger font, right? So engineering drawings usually don't use a lot of line weights, and architecture drawings use a lot of line weights. Okay, now let's jump to the last part of our chapter, which is just some Q&A. Now let's see what we have covered so far. Let's go into our objectives. So we have identified the vertex edge plane, identified solids, identified surfaces. We drew points, lines, arcs, circles, ellipses. We draw an inscribed octagon and a hexagon within a circle. Bisected lines and angles. Drawn arcs using the tangent method. Line type, line weights. Identify different types of line types. We did the symmetrical sketch, and the last one is left is Q&A. Now we'll do this Q&A. It won't take us much time. We'll go through pretty quick. Now the first question is, explain why the knowledge of basic geometric principles is important for a drafter. Now some of you guys might say, hey, you know, why do I need to go through all that? I'm just going to use AutoCAD, and AutoCAD, it makes drafting so easy, right? But not always you have access to AutoCAD. For example, if you're on the site and the client is going to ask you, or the contractor will ask you, hey, I don't understand what this is, so can you just sketch it out for me? And you don't have access to a computer there, so you have to sketch really quick, and you have to show it to him right then and there. So that's where, you know, it's important to understand how to draw, how to do some basic geometric shapes, right? When you're working with any design, the design never starts with a completed drawing. It always starts with some kind of a concept drawing. So to make a concept drawing, you would use a pencil and a paper, and you would scribble, and you would sketch on the piece of paper. If you were making the building, you would just go ahead and sketch something like that, right? And you would work with the shapes, you would work with the proportions, you would work with the masses, you would work with so many different things. And unless you know how to work with some basic shapes, you won't be able to do that. And again, you need to know really basic stuff. You don't need to be a pro in geometry for doing any of these drawings. You just need to know or have an idea of basic stuff. Okay? Now, the next one, how should a point be represented on a drawing? Now, a point, as I said, is somewhere where the two lines meet and the intersection is a point. So I could represent it on a drawing just by a dot, just like that, or I could even represent it with the X, or if I wanted, I could represent it like that. Okay? Now the next question, what does it mean when two angles are complementary to each other? Okay, complementary to each other is when two angles lie within how much? 90 degrees. Okay, so what I would say is, if this is 60 and this is 30, then this angle is complementary to this angle. Okay, and it makes a total of 90 degrees. Now when we go to the next one, what does it mean when two angles are supplementary to each other? Supplementary meaning they are at an angle or a total angle of 180 degrees, right? So this is 100 degrees, then how much is that going to be? That's going to be 80 degrees. And then I could say that these two angles are supplementary to each other. Okay? Now we have a few more questions. Now define what is a triangle. A triangle is something that has 1, 2, and 3 edges, right? Or one vertex, 2 vertex, and 3 vertex joined by lines. Okay? Now again, I have explained 3 different types of triangles. One was equilateral, then isosceles, and scalene. Okay? The triangle is a 2-dimensional shape. And what is this called? A plane. What is this called? A pyramid. Is it 2-dimensional or 3-dimensional? This is 3D. This is 2D. Now the measures of the triangle, it totals to 180 degrees. You have to remember that. It's pretty important. So if I have a triangle, if this is 90 degrees, this is 45, and this is 45. So if I add it up, 45 plus 45 plus 90 is equal to 180 degrees. Correct? 90 is equal to 180 degrees. Now what is a quadrilateral? Now quadrilateral has 4 sides. So a rectangle is a quadrilateral, then rhombus, then square, and parallelogram. All these are quadrilateral because it has 4 sides. Now the measure of these 4 sides is going to be how much? The total measure is going to be, if this is 180, this is 100, and this is going to be 80, 90, 90. So the total measure is equal to 360 degrees. So 90 plus 90 plus 100 plus 80 is equal to 360 degrees. Again, what you have to remember, it has 4 sides, 1, 2, 3, and 4. Okay, so that's what a quadrilateral is. Now, what is a polygon? Now, a polygon is a plane surface bounded by closed lines. For example, a triangle is a polygon. This is a polygon. Could be any shape, but it has to be closed and it has to be bound by lines. Okay, so that's your polygon. Now let's see what's a regular polygon. Now in a regular polygon, when all the angles and the sides are equal, it's called a regular polygon. Now it could be a hexagon, it could be an octagon, It depends what number of sides, right? Now again, an equilateral triangle is a regular polygon, but the others are not. If I talk about a square, it is a regular polygon, but a rectangle is not. Why? Because even though it has the same angles, it doesn't have the same sides. Like for example, if this is 5, then this is 7. In this case, if this is 5, then this is 5, and that is 5, and this is 5. Okay? So again, a regular polygon is something that has equal angles as well as equal sides. So with that, I conclude chapter 2, and the chapter 3 that we have is going to be orthographic projections. So we'll see you soon. Okay? Thanks.